data set on a bunch of different cars, and let's see, reasonably recent data. You can find data sets like this for like 1970 with car names you don't recognize anymore. And you can see sticker price, miles per gallon, horsepowers in there. So it'd be nice to visualize this data set, right? But we've got like a dozen columns and 400 car models to consider. I could try a scatter plot of like each column versus each other column, but that's going to be like 12 squared things. And that's actually sometimes a good idea. That's called a matrix of scatter plots, but it's a pain to do in Excel. There's this other idea called a parallel axis plot. We're used to having like this axis is the y-axis and this axis is the x-axis, right? Not on the graph, or not on the sheet here, but vertical is x-axis and horizontal is y-axis. And those axes are perpendicular to each other. And when we draw things in 3 dimensions, the x, y, and z axes are all perpendicular to each other. Someone said, what if we draw the axes parallel to each other? So we're going to follow this little link here. I've got it up here. This isn't exactly the same data, but it is car data. So this is the cylinders axis, and parallel to it is the size of the motor axis, and parallel to that is the weight of the car axis. And then a single car is represented by drawing a line from like this car has 4 cylinders, has this displacement, has this weight, has this horsepower, has this acceleration. So one line here, let me see if I can. Well, so there's some cars with 3 cylinders apparently in this data set. And so this is an interactive plot. You can highlight those and see where they go on the other stuff. Yeah?
So the slope really doesn't mean anything at all?
It does a little bit. What do you think is going on here? Horsepower, let me reload it. So this is the horsepower axis, high horsepower, low horsepower. And this is the acceleration axis. So what's this telling us?
More horsepower, the quicker the acceleration.
Yeah, the high horsepower cars, you would think they would have good acceleration, right? And it's true they do, but this is acceleration measured in time. And so good acceleration is a low time. So here seeing, does slope matter? Well, I see a negative correlation, right? I see negative slope for large things and positive slope for small things. So that's a negative correlation.
So it's important to put things next to each other that are correlated.
Yeah, so that's the trouble with a parallel axis plot. How do you know what order is best to put the axes in? And someone has some rules, but I've never actually memorized them or anything. So here you can see negative correlation between 2 things. Here you can see positive correlation between weight and horsepower, right? Things with a high weight tend to have a high horsepower, although there is some downsloping. Another issue is if I just graph the data the usual way, look, I've got like between 3 cylinders and 8 cylinders, but weight goes from 1,600 to 5,000. So each of these axes gets its own scale. If they were all on the same scale, then cylinders would just be like down here, 3, 4, 5, 6, 7, 8, and horsepower would be way up here. So you have to rescale each axis to make a decent plot. So that's parallel axis or parallel coordinates plots. If you're using R or Python, they're easier to do. Excel can actually kind of do them, but you have to rescale each variable yourself and use the line type rather than the XY scatter type. So visualizing high dimensional data is kind of important every now and then.